Chapter 17 Physics, question number 789. But before that, I want you to write a small note out of this. Write down relating velocity and angular velocity. Write down the speed of an object traveling around a circle has a relationship with its radius. This can be equated as follows. Put a comma and write down speed equals angular velocity into radius, v equals omega r. Write that, and then let's move to question number 7. You should try these questions by yourself first, and after you have tried them, we are discussing. Watch this after you have done it by yourself. Question number 7. The angular velocity of the second hand of a clock is 0.105 rads per second. If the length of the hand is 1.8 centimeters, calculate the speed of the tip of the hand as it moves around. It is quite easy then, because they have already given all the details we need. So I will do it here itself. So we have the equation v equals omega r. That is the equation. So here v is what they are asking for. Omega is 0.105, and then r is equal to 1.8 centimeters. But you can't you can actually leave it in 1.8 centimeters, but if you convert them into meters, you have to be very careful about the units. If they are asking in meters per second, then of course you have to use it in you have to convert that into meters. But here they have not asked in any specific unit, so you can leave it at 1.8. Then we have to do the calculation. When we do the calculation, 0.105 multiplied by 1.8 is the length, is equal to 0.189 centimeters per second. You can round it off to 0.19. You can round it off to 0.19, and then you will get the answer v equals 0.19. Then what are the units? Centimeters per second. Centimeters per second, cms minus 1. Right. All right, you understood that. Now let's go to question number 4. Question number question number 8. A car travels around a 90-degree bend in 15 seconds. The car travels around a 90 degrees bend in 15 seconds. The radius of the bend is 50 meters. A car travels around a 90 degrees bend in 15 seconds. The radius of the bend is 50 meters. Determine the angular velocity of the car. So how are you going to figure out the angular velocity? Angular velocity, now you know the equation for angular velocity. Angular velocity, omega equals delta theta divided by delta t. Delta theta divided by delta t. Now here delta theta is 90 degrees. 90 degrees is 2 pi divided by 4. Right? 2 pi divided by 4. 2 pi is 360 degrees. That divided by delta t is, they are saying it travels around the bend in 15 seconds. So then you divide it by 15. Then you get 2 pi over 4 multiplied by 1 over 15, right? So then you get 2 pi over 60. 2 pi over 60 is the answer. Then 2 pi over 60 is how much? Did you do the calculation? If you didn't do, let's do it here. 2 pi over 60 equals 0.105. 0.105 is the answer. 0.105. What are the units? Rads per second. Rads per second, right? So those units you have to be very careful about. Then part B. What is part B? Determine the speed of the car. Determine the speed of the car. So now that is quite easy. Why? Because we know the equation. V equals omega R. Right? Now we know omega 0.105 multiplied by what is R then? R is the radius. The radius is given by 50 meters. The radius of the bend is 50 meters. So then multiplied by 50. So 0.105 multiplied by 50 is 5.2 meters per second. 5.2 meters per second. If it is difficult for you to do it with your mind, please use the calculator, then you will get the answer. 5.2 meters per second. So that is question number 8. Let's go for question number 9. A spacecraft orbits the Earth in a circular path of radius 7,000 kilometers at a speed of 7,800 meters per second. Now they have given the speed and they have given us the radius also, and they are asking for the angular velocity. Determine the angular velocity. So that is quite easy once again. Only thing is you have to be cautious about what details that they have given, and use the details that they have given appropriately. Now spacecraft orbits the Earth in a circular path. So let's use the equation. So at a radius of 7,000 kilometers at a speed of 7,800 meters per second. Here meters per second that they have given. So let's use, you have to put the kilometers and meters, you have to make it comparable. So that means it is the easiest is to convert 7,000 kilometers into meters. So now what is the equation for us? V equals omega R. But they are asking for omega. You can get omega equals, you divide both sides by R, then V upon R. Right? So V upon R, omega equals V upon R is the equation. So we can use that equation and find the value. So let's see how we can do it. We have the equation V equals omega R. Then from that we got omega equals V upon R. Now let's substitute the values. What is V? They have given the speed of the object is, speed of the spacecraft is 7,800 meters per second. 7,800 meters per second. Then radius is given as 7,000 kilometers. You have to convert that into meters by multiplying by 1,000. 7,000 multiplying by 1,000 means adding 3 zeros. Then 2 zeros to 2 zeros get cancelled out. Then you get 78 divided by 70,000. You do the calculation, then we'll do it. 78 divided by 70,000. So when you divide 78 by 78 by 70,000, you get 0.0011, you can write it as 1.1 into 10 to the power minus 3. So your final answer is 1.1 into 10 to the power minus 3. What are the units? What are the units? Here it is rads per second. Why? Because we are dealing with angular velocity, rads per second. Hope you understood that.